truck moves with an uniform. Let me make it small so that we can easily accommodate. Truck starts from rest and travels a distance with uniform acceleration. Okay, then I need acceleration, then moves with uniform velocity, then undergoes retardation and finally comes to rest. If truck starts from rest, if telling it's a rest, we'll write it rest. It covers a distances. Then it will cover a distance 2s. I have to show the distance mono. Okay, and finally it will cover a distance 5s. This much of only information. It's telling now what will be the A1. Okay, call this is it's a retardation. Or we'll write alpha beta like earlier. So the time of journey, this will be different. No? So this is T1. This is T2. So here the truck will acquire a maximum velocity. It will continue its uniform velocity motion. Here uniform velocity, acceleration, retardation. If you want, I'll write that also, retardation. Uniform speed here. Here it will be accelerated motion. First, the speed of the truck will increase. Then it will move with a constant speed v for distance 2s. Then it will undergo retardation. Some brakes are applied, it will undergo retardation, finally comes to rest. It will cover the distance, this is the thing. Okay, now let's get all the, we're asking the ratio of average velocity to maximum. Maximum velocity is here. This is what maximum velocity. Let me write it. VM is asking average velocity to this one. How you define the average velocity? Distance covered by time taken. First, we'll write all possible equation. Alpha VM square equal to 2 alpha s. This is for accelerated motion. Okay, I'll write it in detail so that everyone will understand. VM square minus 0 square equal to V square minus 2 square equal to 2AS formula. VM square minus 0 square equal to 2 alpha S. This is the thing. So this will become 1. Come for this. This will be a test 0 square. Initial velocity VM square 2 minus beta 5s. It will undergo retardation here and finally comes to rest. So this will become VM square is equal to minus 10 beta s. We'll get relationship between alpha and beta. So equating these two to 1 and 2. So 2 alpha s equal to 10 beta s, or alpha equal to 5 beta. We'll see what all help we can get it. Huh? Okay, after getting alpha beta, then we can bring the times. How to get this will be VM is equal to alpha T1 from the formula V equal to u+at formula. So finally, VM is equal to alpha T1. Similarly, what is this one? 0 equal to VM minus beta T3. Beta equal to alpha by 5. Okay, there's a relationship between, okay, equating this 3 and 4, we'll get relation between T1 and T3. So alpha T1 is equal to alpha by 5 T3. So even T3 is equal to 5 T1. Any help? We'll see that one. So now average velocity, let me directly get into average velocity. Distance covered. Five s by total time T1 plus T2 plus T3. Do we know T1, T3 as some equation is what we have? Let's keep it either, but we don't know T2. What is T2? We have some information. What is that? T2 is equal to Vm is equal to distance covered in uniform motion is 2s by T2. So T2 is equal to what? You can write it as 2s by Vm. Vm, what we can write it as? Alpha T1. Vm, we can write it as alpha T1. Okay, agree. This will be, or S is equal to Vm, you can write it as 2 alpha S. In terms of alpha, you can Vm square or whatever be different. So this is the thing. Okay, now we have some everything. I should bring Vm into the picture. That's all. What is our condition? The Vm has to be brought it here. So this will become 8s T1 T3 code 5 T1. So this is T1. This is T1 T2. This will be 5 T1, or this will be 8s equal to 6 T1 plus T2. And write it as 2 alpha s. 2 alpha s. This is 2 alpha s. Alpha s get cancelled. So 8 Vm by so this will be 6 to 12 plus 2. So 8 Vm by 14. The ratio of average velocity to maximum velocity. So what is the next step? V average by Vm equal to 4 by 7. Nothing is there altogether about this. Is it? I just took help of all these conditions. This is the very important, I think, during uniform velocity motion. I think this is what this didn't help. Look at now. So this is the T2 equal to 2s by Vm. Again, you are interested, plot the graph, everything. Almost things are same. You can go for the plotting graph. First it will be acceleration, then retardation. Some rough graph, I'll show it. First it will accelerate. First it will accelerate. Then uniform velocity motion, then retardation. What about ST graph? The ST graph will be first the body will accelerated motion, uniform velocity, retardation comes to rest. This is a position versus time graph. Almost the method is same. So here it will alpha, the acceleration is alpha, here retardation is beta. It will start from rest, and again the slope should be 0. when you're plotting. The slope here should be 0. Here also the slope should be, because it will accelerate from rest and it finally come to rest here. This should be a straight line. This part should be a straight line. Okay, yeah. Okay, the overall description, what we did. Okay, there's a problem. Yeah. I think it's all about understanding the situation, then writing equations of motion, then what is the unknown thing that is asked, how we can determine it. It's what we have to constantly search for it. So these are the most of the numericals of excited motion will be of this kind. Okay, we'll take the next